We now discuss the solution of a problem from the section Coordinate Geometry. This problem is on the directrix of an ellipse. The problem has appeared in Joint Entrance Examination Main held on 27th July 2021 in the morning shift. The problem is a ray of light through 2, 1 is reflected at a point P on the y-axis and passes through the point 5, 3. If this reflected ray is the directrix of an ellipse with eccentricity 1 by 3 and the distance of the nearer focus from this directrix is 8 by under the square root of 53, then the equation of the other directrix can be, the four options are given to us. We are given a ray and we are given that this ray of light through this point 2, 1 is reflected at a point P on the y-axis and the reflected ray passes through the point 5, 3. And if this reflected ray is the directrix of an ellipse whose eccentricity is given to be 1 by 3 and the distance of the nearer focus from this directrix is 8 by root under the square root of 53, then the equation of the other directrix is to be calculated. And one of the following is an answer. So, we discuss the solution of this problem in detail. Solution. We are given a ray of light through the point 2, 1 is reflected at a point P on y-axis. Let's look at the diagram. X-axis, y-axis intersecting at the origin. And you are given a ray of light through 2, 1 is reflected at a point P on the y-axis. And it is reflected and the reflection passes through the point 5, 3. The reflected ray passes through the point 5, 3. Now, we want to find the equation of the reflected ray. But we are given the reflected ray is passing through 5, 3. And unless one more point is given on it, we cannot find the equation of it. Otherwise, the slope of this line should be known. So, what we do is we take the reflection of this 2, 1 in the y-axis and that will be minus 2, 1. Now, the mirror image of the point 2, 1 in the y-axis is minus 2, 1. Reflection this way, minus 2, 1. And this minus 2, 1 lies on the reflected ray. So, this lies on it, therefore, it is extended. So, now we have 2 points on the reflected ray and we can apply that 2-point formula for the straight line equation. So, thus the line joining 5, 3 and minus 2, 1 is the reflected ray. And the equation of the reflected ray is, if this is x1, y1 and this is x2, y2, then the reflected ray is y minus y1 is equal to y2 minus y1 by x2 minus x1 multiplied by x minus x1. So, we write down y minus 3 is equal to 1 minus 3 by minus 2 minus 5 into x minus 5, x minus 5. This is minus 2 by minus 7 and this is 2 by 7. So cross multiplying, we'll get 7 times y minus 3 is equal to 2 times x minus 5, and simplifying, we'll get 2x minus 7y plus 11 is equal to 0, and this is the directrix of an ellipse, and it is given that this reflected ray, this equation, is the directrix of an ellipse. And now let's look at the diagram. So this is our x-axis, y-axis, and there is the ellipse and a directrix and its foci f1 at AE star, f2 minus AE star, and one of the directrix is x is equal to a by e, the other is x is equal to minus a by e, and the distance between the directrix x is equal to a by e and the nearer focus f1 AE star is a by e minus AE, and the distance between the two directrices is 2a by e. So now distance of the nearer focus from the directrix is a by e minus AE, and this is the distance between the two directrices, that is 2a by e. And let's take one of the directrix is 2x minus 7y plus 11, and the other directrix is parallel to it, and we can take it as 2x minus 7y plus lambda is equal to 0. Let's discuss further in the next slide. We are given that this reflected ray is the directrix of an ellipse with eccentricity 1 by 3, and the distance of the nearer focus from the directrix, this directrix, is 8 by root 53. It is given E is equal to 1 by 3, and the distance of the nearer focus from the directrix, we have seen a by e minus AE is equal to 8 by root 53. In this, put E is equal to 1 by 3 in this. So that will imply a by 1 by 3 is 3a minus a by 3 is equal to 8 by root 53. 3a minus a by 3 is 8a by 3 is equal to 8 by root 53. 8 cancels. A is equal to 3 by root 53. Let the other directrix be 2x minus 7y plus lambda is equal to 0. Why? Because the other directrix is parallel to this directrix. So this is the equation. So now the distance between the two directrices, this one and this one, is mod of lambda minus 11 by under the square root of a square plus b square. That is modulus of lambda minus 11 by under the square root of 2 square plus minus 7 whole square is equal to the distance between the two directrices. We have seen 2 times of a by e, and that will imply modulus of lambda minus 11 by root 53 is equal to 2 into a is 3 by root 53, 1 by e is 3. So 2 3s are 6, 6 3s are 18, 18 by root 53, root 53 cancels, and we will get modulus of lambda minus 11 is equal to 18, and this will give you lambda minus 11 is equal to plus or minus 8, and that will give you plus or minus 18. Modulus of lambda minus 11 is equal to 18. That will imply lambda minus 11 is equal to plus or minus 18, and that will give you lambda is equal to 18 plus 11, or lambda is equal to minus 18 plus 11, and that is lambda is equal to 29, or lambda is equal to minus 7. So therefore the equation of the other directrix can be 2x minus 7y plus lambda, that is plus 29, or 2x minus 7y minus 7. Let's look at our options. Our answers: 2x minus 7y plus 29 is equal to 0, or 2x minus 7y minus 7 is equal to 0 appears again is the option 1. Therefore, our answer is option 1. So that is the discussion of the solution of the problem from the coordinate geometry based on the directrix of an ellipse. I am sure that you have understood the solution of this problem and concentrate on the coordinate geometry for more number of problems. I wish you all the best. Thank you.